In real life, we don't actually get nice, easy shapes to find the area of. We don't get rectangles and triangles and circles. We usually get bits of it. So like this example here, we often get strange shapes. The trick is to split your shape up into simpler shapes and use those simpler shapes to calculate the area. So in this example here, we would cut it up along here and make the shapes that we've got below. Once you've done that, you need to find out the area for each separate shape. So I'll call this shape 1, 2, and 3. So for shape 1, that's a rectangle. Shape 2, that's a rectangle, and shape 3, that's a triangle. So for rectangles, we need length by width. Now again, the problem is we need to look for lines that go in the same direction. All the vertical lines, this one, and this one, and even this little one here, can be looked at together to work out the different lengths. So I know that I've got 30 all the way from here to here. I've got 20 here, which would fit here. So that means this little one here is going to be 10. So I'm just going to put that in as a different colour. So that one there is 10. And I'll need that for the triangle. If I'm looking at the sides that go horizontally, and I'll colour those green, there's one here, one here, and one here. I can use the three of those to work out any side that's missing. So again, for this triangle and for square 1 or rectangle 1, this side here is one we don't know. And I can work that out by saying 30 up here minus 16 makes 14. So I'm going to have 14 meters there. Alright, so let's look at area 1. Area 1 here is a rectangle with the sides 20 for the length and width of 14. So area equals length by width, substitute in 20 by 14. For area 2, again we have a rectangle. Its sides are already on there, we don't need to calculate or work anything out because its length is 30 and its width is 16. So let's put that one in. Area equals length by width equals 30 by 16. And for area 3, which is the triangle, we need half base times height. Area equals half base times height. The base we worked out is this 14 over here, and the height will be 10. So that's going to be equal to half 14 by 10. So let's work those out. Now at the top we've got 20 by 14, so that's the same as 280 square meters. The next one's going to be 480 square meters, and the last area is going to be 70 square meters. That means the total area is all those three added together, which is 280 plus 480 plus 70, which equals 830 square meters. So in this video I'm going to show you how to work out the area of some common shapes using the formulas from the previous video. So let's have a look at the first one. So in the first one we've got a full circle, so the area of a full circle is pi r squared. So it's just going to be pi times 3 times 3 which is 9. So it'll be the same as 9 pi's, which is 28.8 millimetres squared. In the next example, we've got only half a circle. So the area for this shape is going to be half of a circle, half of pi r squared. So it's a half of pi times... Now, the problem we've got here is that the 7 is the diameter of the circle, not the radius. So I need to put 7 over 2 squared. That equals 19.2 metres squared. This next example is a mixture of two different shapes. First of all, we've got the square, which is 11 by 11, and then we've got two half circles, this one here and this one here. And because they're two half circles, both with the diameter of 11, they make one full circle with a diameter of 11. So the area for the square is going to be length by width, which is equal to 11 times 11, which is 121 metres squared. And for the area for the whole circle, which is the two halves put together, will be pi times r squared. Now this time r is half of 11, so because 11 is the diameter. And the answer to that is 95 square metres. And then if we add those together, we get 216 square metres. So that's the area for that composite shape, which is a circle and a square put together. In the next example, what we have here is a square with holes cut out of it. So the square is 12 by 12, and the holes cut out of it would make a whole circle. So the area for the square is going to be 12 times 12, length by width, equals 144 square millimetres, or millimetres squared. For the circle, the area is going to be equal to pi times the radius squared, the radius being 6 in this case, because 12 is the diameter of the circle, so it'll be 6 squared, which is 36. So the answer to that's going to be 113 square millimetres. We need to subtract these two numbers because the circle is a hole in the square and it's been taken away. So the total area is going to be 144 minus 113, which is 31 square millimetres. To find the area of this red annulus, we need to find out the area of two circles and subtract one from the other, because the middle circle is a hole in the annulus, a bit like a donut. So let's look at the first part. The main circle is 50 millimetres across, so its area for the whole circle is going to be pi times 50 squared, oh, not 50 squared, 25 squared, because 50 is the diameter, and the answer to that is 1963 square millimetres. That's still a lot of square millimetres, isn't it? Now, the centre area is in centimetres squared, so we're going to have to make an adjustment, but we'll work out the area first, and then I'll show you how to convert the areas. So area is going to be equal to pi times 2.5. Well, we need to halve that, so it'll be 1.25 squared. 4.91 centimetres squared. So the area of the red annulus is going to be equal to the outside circle area, or the total area, which is this one here, and I'll call it O for outside, and I'll have to subtract the inside area. Now, the only problem with that is that when we do that, we have to make sure that they're both in the same units. This one is in millimetres squared, that one's in centimetres squared. To change millimetres squared into centimetres squared, the decimal point needs to move 2 places, because one place would change millimetres to centimetres, but I have to do it twice because they're squared. So that means I've got 19.63 minus 4.91, and the answer to that is 14.72 centimetres squared. Let's round that off to 2 places, because we only had 2 places in both of these numbers up here, so that would be 15 centimetres squared.